Hi everyone, it's Math with AUB. Let's see, find out how to deal straight line in two variables, straight line in two dimension. Let me write general form of the straight line. Straight line in two variables or in two dimension. General equation is given by ax plus by plus c is equal to 0. Linear equation always represents a straight line. Linear equation in two variables. Linear equation in two variables. If we include z, then it represents a space, a three-dimensional concept, a linear equation in two variables. A linear equation in two variables always represents a straight line. Either term of x is altogether missing, or the term having y is altogether missing. Still, they both represents a straight line. Straight line, linear equation in two variables, x is 1, y is 1. Linear equation in two variables, x and y, always represents a straight line. Always represents a straight line. Even when term of x is missing altogether or term of y is missing altogether, still it represents a straight line. It represents a straight line. From line itself, we can easily manage slope. We can easily manage slope. To write equation of a straight line, we need two parameters. Slope, also known as gradient. Slope, also known as gradient, plus a single point. At least a point. To write equation of a straight line, we need a slope and a single point. At least slope and a point. Slope is also known as gradient. When we have given both, we utilize this basic form. It is known as point slope form. Y minus y1 is equal to m times x minus x1, where m is our slope, x1 y1 the given point, x1 y1 the given point, x1 y1 the given point. To write equation of a straight line in two variables, we need two parameters, two things, two elements, slope and a point. Slope is also known as gradient. And denoted by a simple m and at least a single point. To find slope, we have several possibilities. Number one, let me write here. When we have given 2 points, when we are given two or more than 2 points, that's the formula for slope. Mathematically or in words, it is known as rise over run, or difference of abscissa divided by difference of ordinate divided by difference of abscissa. Difference of ordinate divided by difference of abscissas. Difference y is known as ordinate while x is known as abscissa. Rise over run. Difference of ordinate divided by difference of abscissa. Difference of ordinate divided by difference of abscissa. Or from the line itself, we can write the slope. Second possibility, from line itself, minus negative times coefficient of x divided by coefficient of y. Coefficient of x divided by coefficient of y. Here we can easily find slope. Negative coefficient of x a, coefficient of y b, minus a over b is the slope in that case. To write equation of a straight line, we need gradient and a single point. Gradient and at least 1 point. When we have given a gradient and slope, we utilize this equation mostly. Y minus y1 is equal to mx minus x1. It is known as point slope form. We have discussed two possibilities. First, when two or more than 2 points are given, that the formula for slope, y2 minus y1 over x2 minus x1, or difference of ordinate divided by difference of abscissa, rise over run, and from equation itself we can find slope. Negative coefficient of x divided by coefficient of y. Negative coefficient of x divided by coefficient of y. Here negative coefficient of x is a and coefficient of y is b. Coefficient of x is a and coefficient of y is b. That's my tiny effort. Now let's utilize this information that we have gathered here. To write equation of a straight line, always hunt for slope and a point. Slope and a point. Slope is also known as gradient. Let's see and find out. Starting from very basic. Suppose we have given 2 points, 4, 5, 5, 6. Let's see and find out. We have given what we need, slope and a point. Slope plus point. Slope plus point. Instead of single point, we have 2 points. Utilize slope y2 minus y1. Difference of ordinate divided by difference of abscissa. And name them x1, y1, x2, y2. It's up to you. Take them x2, y2. Then this is x1, y1. It's okay. y2 minus y1, 6 minus 5 over 5 minus 4. We have 1 over 1, 1. That is our slope. Either to take this point or this point, you are going to get through. Point slope form utilized. We have point, we have slope, and a point. We are in a position to write equation of a straight line in 2 variables. Point slope form. Point slope form. Y minus y1 is equal to m times x minus x1. Y minus y1 is equal to m times x minus x1. I am utilizing this point x1 y1. Either you can take this one x1 y1. It's up to you. Y minus 5. Our slope is 1 times x minus 4. Multiplying by 1, we have y minus 5 is equal to x minus 4. Mostly in answers or in options, x is positive. X is positive. Shift y minus 5 on the left hand side. I have x minus y plus 5 minus 4, or it is going to be x minus y plus 1 is equal to 0. X minus y plus 1 is equal to 0. That's our required equation of straight line. One can verify the slope from the given information. From the line itself, we can manage slope minus negative time coefficient of x and coefficient of y. Coefficient of x is 1, coefficient of y is minus 1. Coefficient of x is 1, coefficient of y is minus 1. Negative times coefficient of x divided by coefficient of y. So we have same slope 1. That's the verification for you. Whenever we have given 2 or more than 2 points, that is the strategy to write equation of a straight line. First find slope, then take any point. That's our answer in that case. Point slope form. Point slope form. Let's apply this to some in-depth questions. Moving one step further, let's see and find out. Suppose we have given a rectangle or a square. Let me draw a rectangle for you. Equation of this line is, this side is 3x plus 2y plus 5 is equal to 0, and we have given a point here 2, 3. Let me name them A, what is A, B, C, D. A, B, C, D. Now we are asked to find equation of the side. Equation of side DC. Equation of side DC. Equation of side DC. Let me write DC independently. DC. D, no point C is given to us. 2, 3, 2, 3. This is a line segment. Equation of a line segment or line, they workable. Same concept work here. Now we know that opposite sides are parallel. Opposite sides are parallel. Opposite sides are parallel. In case of line, when lines are parallel or line segments are parallel, their slopes are equal. Their slopes are equal means slope of AB is equal to slope of CD. Slope of CD. Slope of AB, slope of CD. Why? Parallel lines have same slope. That's our fact. We are going to utilize here. Parallel lines have equal gradients. Equal slopes. Utilizing this fact, we can easily manage the slope of CD or DC, whatever you say. M is equal to negative. How to determine slope from the line itself? The slope from the line itself formula is negative coefficient of x, negative times coefficient of x divided by coefficient of y. So I have negative times coefficient of x is 3 in that case. Coefficient of coefficient of y is 2. Coefficient of y is 2. Minus 3 over 2. Minus 3 over 2. So slope of this side is AB is 3 minus 3 over 2. Same is the slope of this line by virtue of parallel lines. By virtue of parallel lines. So the slope of DC is minus 3 over 2 and the point we have already 2, 3. Look at this. We arrive at the same situation. We have a gradient. We have a point. We can easily write its equation. So equation of CD is given by equation of CD y minus y1 is equal to m times x minus x1 is equal to 0. I am taking, we have only lone point to be taken, y minus 3, slope is negative 3 over 2, x minus x1 is r2. Shift to here, from right hand side to left, from division to multiplication. 2 times y minus 3 is equal to negative 3 times x minus 2. So I have 2y minus 6 is equal to minus 3x plus 6. Mostly in answers, coefficient of x is positive. So shift this quantity there. From right to left, it will become 3x. 2y intact, same, minus 6. Positive 6, it will be turned to negative, minus 6. So I have 3x plus 2y minus 12 is equal to 0. That's our required equation of CD. One can verify the slope minus negative times coefficient of x, coefficient of y, coefficient of x, coefficient of y. Okay, we have managed the equation of CD by virtue of parallel lines, parallel sides. If sides are parallel, their slopes are equal. Parallel lines have equal gradient. Parallel lines have equal gradient in 2 dimensions, in x and y. Okay, what about how to hunt equation of BC? How to hunt equation of BC? It's also very easy. Moving to another concept of perpendicular lines. Okay, cool. Let me raise this. How to find equation of the side BC? Look at this. We know that each angle of a rectangle is of 90. When now the side AB and BC are perpendicular to each other. AB is perpendicular to BC. AB is perpendicular to BC. AB is perpendicular to BC. When lines are perpendicular, when lines are perpendicular, when lines are perpendicular, when lines are perpendicular, some people write orthogonal, it's same, then product of the slopes is equal to negative unity. Then the product of the slope is equal to negative unity, or some writer utilize the concept slope of one line is the negative reciprocal of other line. Slope of one line is the negative reciprocal of the other. Slope of one line is the negative reciprocal of the other. Okay, both they work here. Now BC. Look at BC. Still I have a single point C 2 3. See, I have to manage its slope. Slope of AB is given to me. Slope of AB is given to me. AB and BC are perpendicular. Slope of AB is 3x plus 2y plus 5. So its slope is m1 negative coefficient of x divided by coefficient of minus 3 over 2. To find equation of BC, it will be turned to negative reciprocal. Change the symbol and make it reciprocal. Change the symbol, make it reciprocal. Change the symbol, make it reciprocal. This is the slope of RBC. This is the slope of RBC. This is the slope of RBC. Again, we have gradient and a point. We can utilize its equation. Look at this. Slope of AB is minus 3 over 2. Slope of AB is minus 3 over 2. And BC is perpendicular to AB. And BC is perpendicular to AB. By virtue that each angle of rectangle is of 90. Is a right angle. By virtue of perpendicularity, if slope of AB is minus 3 over 2, then slope of BC is going to be negative reciprocal of this one. Negative reciprocal. Changing symbol, make it reciprocal 2 over 3. Now I have slope and I have point. I can easily write equation of BC. Equation of BC. I have y minus point slope form, basic form to be utilized, point slope form. y minus y1 is equal to m times x minus x1. I have y minus 3 is equal slope positive 2 over 3 times x minus x1 2. Shift 3 here, it will become 3 times y minus 3, 2 times x minus 2. I have 3y minus 9 is equal to 2x minus 4. Shifting this quantity there, keeping in mind mostly x quotient of x is positive, 2x minus 3y, positive 9 minus 4. So I have 2x minus 3y plus 5 is equal to 0. Is equal to 0. One can find its slope direct and verify m2 is negative coefficient of x over coefficient of y. Minus plus m2 is equal to 2 upon 3. Or one can verify the product of the slope is going to be minus 1. Slope of AB is r minus 3 over 2 and the product and the slope of BC. Slope of AB is minus 3 over 2 and the slope of BC AB is minus 3 over 2, BC is 2 over 3. 2 over 3 cancelled out. I have negative unity. I have negative unity. It's my tiny effort to you to explain to you how to write equation of a straight line in two variables. Equation of a straight line in two variables. Next time we'll discuss what do you know x-intercept, y-intercept, how to graph them, and how to find angle between two lines. Upcoming adventure. It's all by itself. Next.